The effect of the number of rectangles used in the approximation. Difference in the approximations when using different number of rectangles. So here we see 2 rectangles. We're summing up 2 numbers as opposed to 8 rectangles. So with 2 rectangles, there is a much larger error. 8 rectangles has a smaller amount of error. Right? It's much better approximation with more rectangles. And there goes my page. Clearly, using more rectangles will give us a more accurate approximation of the area under the graph. And there we go. The curve with rectangles from prior partitions of A to B. So here we have Riemann sums, and we are putting in more and more partitions. So finer partitions create more rectangles with shorter bases. So notice that the change in x is decreasing as the number of rectangles is increasing. So here we have a right Riemann sum on top, left Riemann sums are on the bottom, right? And then the first row, first column I should say, is with 10 partitions, then with 30 partitions, and then with 50 partitions. Right? So notice that the right Riemann sum for 10 partitions was 0.385. The left Riemann sum for 10 partitions was 0.285. For 30 partitions, the right Riemann sum was 0.3502. It's coming down a little bit, right? Because this is going to be an overestimate, right? We're overestimating when it's an increasing function for the right Riemann sum. And we're underestimating for when we have a left Riemann sum and the graph is increasing. So for the 30 rectangles, the left Riemann sum is 0.3169. So notice that the left Riemann sum is getting a little bit larger because we're having a better estimate. We're underestimating less. And the right Riemann sum is getting a little smaller because we're overestimating less. Now with 50 rectangles, the right Riemann sum is 0.3434. The left Riemann sum is 0.3234. So those are coming closer together as we are getting, or as our approximation is getting better and better. As the number of subintervals increases indefinitely, the Riemann sums approach a limiting value, the area under the graph. And now we're waiting for the big finish. Here we go. This fact suggests that finding the exact area under the curve can be obtained by taking the limit of any of these sums when the number of partitions n increases to infinity. And that gives us the definite integral. So we have the left Riemann sum on the left-hand side, the right Riemann sum on the right-hand side, and the exact area in the middle. In upcoming lessons, we are going to learn how to find the exact area. All right? Thanks for watching. Bye for now.